Hi, good morning to all my students. Today in this video, we are discussing permutations and combinations and combinatrix. Permutations and combinations, otherwise called combinatrix. I have explained some questions in this video in my notes. Please go through it very carefully. All questions are upcoming and already given in JEE mains previous questions. Why I am discussing like this? Because the sorts of questions, the types of questions naturally given in JEE mains, how they will be, every student must come to know, and how to answer them must come to know. That is why I am dealing only the previous questions and expected upcoming questions for the competitive exams. Not only JEE mains, any central competitive exam, it will be useful. Now, combinatrix, fundamental rules. There are three fundamental rules of combinatrix. First one is addition rule. Second one is multiplication rule. Third one is pigeonhole principle. They are very easy to state, but they are very easy to state. They are useful in a number of diverse and often rather complicated situations. Addition rule. How the addition rule will be applicable, how it will be. These combinatrix is only meant for general affairs with common sense and social affairs and the things and the situations around us in the society, or otherwise on number theory, the questions may be dealt. You see this question, a man can leave Mumbai for Mumbai by train in 7 ways, by air in 4 ways, and by sea in 2 ways. The total number of ways of his leaving Mumbai is addition rule. What is that? 7 plus 4 plus 2 equals to 13 ways. So in 13 ways, that man can leave for Mumbai either by train or by air or by sea, like this. Very simple, but while listening the question, the student naturally will be confused to give the answer. When the question is, a man can leave for Mumbai by train in 7 ways, by air in 4 ways, and by sea in 2 ways, how many ways can he leave for Mumbai? Naturally, sometimes the student may be confused, but the rule is very simple. You see here, a class consists of 10 boys and 10 girls. In how many ways a class leader can be selected? In how many ways a class leader can be selected? 10 plus 10, 20 ways. How can we say like this? Leader can be a boy or a girl, but not both. So, boy or girl means plus. So, 10 plus 10, 20. There are 20 ways we can select a class leader. To make you somewhat understanding for this addition rule, I have given like this. Multiplication rule. For the multiplication rule, you see, in how many ways a man can wear 5 shirts and 4 pants? In how many ways a man can wear 5 shirts and 4 pants? So for this is multiplication. Because I told multiplication rule, naturally you can multiply 5 into 4 20 ways. But that is not the way. You have to understand the heart of the question and you have to give the solution. So how much can you explain? How much you can explain about it? That is very important. For each shirt, there are 4 pants to wear. For each shirt, there are 4 pants to wear. Thus required ways. Now, we can explain like this. For each shirt, there are 4 pants. 5 shirts are there. For each shirt, 4 pants. Another shirt, 4 pants. Another shirt, 4 pants we can wear. Like that 5 into 4, 20 ways. 20 ways we can wear 5 shirts and 4 pants. You see the multiplication rule. Here, how many ways one can post 4 letters in 3 letter boxes? This also many of the students are confused to give the answer for this. These are very simple, looking very simple, but reason should be known. You must be rational for that. How many ways one can post 4 letters in 3 letter boxes? First letter can be posted in any one of the 3 letter boxes. First letter can be posted in any one of the 3 letter boxes. 4 letters are there, 3 letter boxes are there. So first letter can be posted in any one of the 3 letter boxes. This job can be done in 3 ways. Similarly, each other job can be done in 3 ways. So required number of ways, 3 into 3 into 3 into 3, 3 to the power 4. In how many ways, similar way, in how many ways 5 prizes can be distributed among 7 athletes? In how many ways 5 prizes can be distributed among 7 athletes? If each athlete is eligible for each prize. In this also, some people are confounded. In how many ways 5 prizes can be distributed among 7 athletes? First prize can be given to any one of the 7 athletes. Thus required number of ways, 7 to the power 5. What is the rational way? what is the reason you are mentioning first prize can be given to any one of the 7 athletes? Second prize, similar way. Third prize, similar way. Like the fourth prize, fifth prize, similar way you can give. 7 to the power 5. You see, another one, you will be again confounded. A man wants to send invitations to his 6 friends through his 3 servants. A man wants to send invitations to his 6 friends through his 3 servants. In how many ways can the man send the invitations among the friends? Again, a man wants to send invitations to his 6 friends through his 3 servants. In how many ways can the man send the invitations among the friends? Each of the 6 friends can receive the invitation. Each of the 6 friends can receive the invitation by any one of the 3 servants. Right? That is reasonable thing. By any one of the 3 servants, each of 6 friends can receive the invitation. Hence, required number is 3 to the power 6. Is 3 to the power 6. This is multiplication rule. Like this, linear permutation, arranging objects along a line. Arranging objects along a line. Circular permutations, arranging objects around a circle. That also you have to know. You see, how many signals can be made by 5 flags? Linear permutation, circular permutation. How many signals can be made by 5 flags from 8 flags of different colors? How many signals can be made by 5 flags from 8 flags of different colors? For that, 8P5. Here, 8 flags are there. 8P5. What is 5? Signals can be made by 5 flags. Signals can be made by 5 flags from 8 flags of different colors. 8P5. This is linear permutation. You see here, permutations for repeated and identical objects. This also was discussed in my notes in this video. Some questions given in the questions given in previous exams, previous competitive exams, I discussed in them permutations for repeated and identical objects. So very easy for that. That is, you see, for example, here engineering is there. Engineering. 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 How many permutations? How many linear permutations? They won't say linear. How many permutations? It is implied linear. How many permutations or the how many arrangements will be there for that word, for the all letters in that word? Then how many letters are there? E, N, G, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters are there. So 11 factorial. But condition is there. Some letters are repeated or identical. Here, how many E's are there? 3 E's are there. How many I's are there? I, 2 I's are there. How many N's are there? 2 N's are there. G's, 2 G's are there. Like this, repeated number of letters are there. Therefore, you have to write total permutations. You see here, 3 E's are there, 3 N's are there, 3 N's are there, 2 G's are there, 2 R's are there, 2 I's are there, 1 R is there, 3 E's, so 3 factorial, you have to keep downward. 3 N's, 3 factorial downwards. 2 G's, 2 factorial downwards. 2 I's, 2 factorial downwards. 1 R, so we need not. 1 factorial we can keep, whether you keep or not necessary. More than 1 only you will keep downwards. And total number 11, all the letters, 11 letters in the word engineering. So 11 factorial by 3 factorial, 3 factorial, 2 factorial, 2 factorial, all intos downwards. This is the way to give linear permutation when the things are, when they are repeated, when the letters are repeated, when the similar identical letters are there. This you have to remember. For circular permutations, here only 2 things. 2 cases. Only 2 cases. Here, the number of ways that 8 beads of different colors be strung as a necklace. The number of ways that 8 beads of different colors be strung as a necklace is. Here, direction is immaterial. For the necklace, direction is immaterial. Since direction is immaterial, number of garlands, 8 beads, no? So 8 minus 1, 7 factorial by 2. Round means 1 you have to subtract. There are 8 beads of different colors. It should be arranged in one necklace. It should be strung in a necklace. Means like this. 8 beads. When 8 beads given, 1 we have to subtract. 9 given, 1 we have to subtract. 12 given, 1 we have to subtract. It is compulsory. So here 8 beads of different colors be strung as a necklace. How many ways we can? 7 8 minus 1 factorial by 2. By 2 why? Because direction is immaterial. When direction comes? When for the people in the round table conference, direction is material. For this necklace, for the garland, direction is immaterial. Direction immaterial means by 2 will come. Direction material means for the party, for the dinner, the persons sitting around the table, only 8 persons, means 8 minus 1 factorial, 7 factorial only we use. We don't use by 2. By 2 when we use, in case of garlands, in case of necklace, we use it. There, in case of necklace and garlands, their direction is immaterial. In this direction you can, or in this direction you can keep the beads. Direction is immaterial, therefore by 2 must come. Otherwise, for the people, for the persons round table, by 2 never comes. You see here, find the number of ways in which 8 different flowers as a garland can be strung to form a garland. 8 different flowers. Then 7 factorial by 2. What is it? 8 different colors, flowers, no? So 7 factorial by 2. A roundtable conference is to be held between 20 delegates of 2 countries. Okay, how many ways they can sit around the table? Only 20 minus 1, 19 factorial. Because they are the persons, they are not flowers or beads. Direction is material. So direction is counted. Like this, so many things we can discuss. A few things we have discussed today. It is somewhat sufficient. Please go through in this video my notes, and I discussed JEE mains questions. Some of the questions I explained it. Please go through it. Before doing all this, you have to share, subscribe, click the bell icon to get more updates. It is very, very important. It is very important to get update videos, because today I started combinatrix, and it will be continued for some days, for some videos, with some videos it will be continued. I will deal the sums, I will deal the core of the subject and the important points of the subject. I will deal, if necessary, for the competitive exams. Unnecessary things in the subject I don't discuss. I will continue like this. Please to get update my videos, share, subscribe and click the bell icon. And if any comments is there, comment section will be there nearby my video. You can write everything, I will respond it, I will answer the questions. Thank you. Thank you so much. Dear students, today we are starting combinatrix or combinatorics containing permutations and combinations. In this video we are discussing upcoming competitive exam questions, dealt with various theory in combinatorics. You see here, naturally these questions look very general and also with the common sense. Let us see this question. All possible numbers are formed using the digits 1, 1, 2, 2, 2, 2, 3, 4, 4. How many numbers? How many digits? 3, 6, 9 digits. 1, 1, 2, 2, 2, 2, 3, 4, 4. Taken all at a time, the number of such numbers in which the odd digits occupy even places. The number of such numbers in which the odd digits occupy even places. On reading the question, you have to understand it first. And next to doing in general way. So if you understand the question, half solved. The understanding the question is half solved. All possible numbers are formed using the digits 1, 1, 2, 2, 2, 2, 3, 4, 4, taken all at a time. The number of such numbers in which the odd digits occupy even places. Such numbers will be 180 numbers will be coming. That will be the answer. How to do? Given digits are 9. They are 1, 1, 2, 2, 2, 2, 3, 4, 4. Here, I have given you 9 boxes for every digit. So I have drawn even places. You see, even places. Second place, fourth place, 6th place, 8th place, even places. Okay, how many boxes? 9 boxes, because 9 digits. The number of ways to arrange odd numbers 1, 1, 3 or the odd numbers at even places. That is the question. What is the question? The number of ways to arrange odd numbers 1, 1, 3 at even places. That is the question. So, even places, how many? 1, 2, 3, 4. In 4 places, how many numbers, odd numbers? 1, 1, 3. So, in how many ways, even places, we can arrange? 4C3. 1, 1, 3. 4C3. First, we have to select. 4C3 is the selection. 4 blanks are there. 3 odd numbers we have taken according to the question. So we have to select 4C3 into. After selection, we have to arrange. How to arrange? 3, 1, 1, 3, no? 1, 1, 3. 1, 1, 3, how many digits? 3 digits, 3 factorial by how many digits repeated? 2 digits repeated. So 2 factorial. So if digits are repeated, you have to write downwards. 3 factorial by 2 factorial. This is the arrangement. 1, 1, 3, 3. 3 factorial by how many numbers, how many digits repeated? 1, 1. 2 digits are repeated. So 2 factorial. Now this is selection and this is arrangement. Total arrangements. So the number of ways we are getting as suggested in the question. Next, the number of ways to arrange remaining even 2, 2, 2, 2, 4, 4 numbers. The number of ways to arrange remaining even 4 2s and 2 4s numbers are 6 factorial by 4 factorial into 2 factorial. This we can arrange in a regular way. How many digits are there? 1, 2, 3, 4, 5, 6 digits. So 6 factorial by how many repeated 2s? 4 factorial. How many repeated 4s? 2 factorial. Downwards you have to keep. This is the number of ways to arrange remaining even like this. Sir, you have kept 4C3 here, selected and permutations. After selection arrangements you said. Here direct arrangement, because after this selection of 4C3, I have kept arrangements. I have done arrangements. Afterwards, arrangements we are doing. So no need to select. So total number of 9-digit numbers that can be formed using given digits. 4C3 into 3 factorial into 2 factorial into 6 factorial by 4 factorial and 2 factorial. Total, you count it, you got 180. That is 180. All possible numbers are formed using the digits taken all at a time. The number of such numbers in which the odd digits occupy even places. by learning this, what you have understood. In this question, first we have to take even places. That is why we have taken selections 4C3, 4C3, and of the 3 digits we make arrangements 3 factorial by 2 factorial. Here we have learned if the repeated items comes, then there should be downwards we have to write. You see here also 1, 2, 3, 4, 4 factorial, 2 fours, 2 factorial downwards, 4 factorial, 2 factorial downwards. Total 6, 1, 2, 3, 4, 5, 6. 6 factorial by 4 factorial into 2 factorial. Like that. So for the repeated cases. Next, various questions. These type of questions are upcoming or already given in 2019 for the shifts, January shift, April shift, JEE mains questions. Because in these permutations and combinations, no theorems. Theorems are there, but all are general common discussion theorems, and those theorems will not be, never be given for the exams. Mostly in this particular combinatrix application, most important. On the application only the questions are given. Because in day-to-day life, for the common sense and for general affairs, in the socio-general affairs, the situations in number system or in marketing or any affair else, all these will be coming. So the student means the coming up, the future citizen must know how to deal these cases to improve the awareness in general thinking. You see here, a committee of 11 members is to be formed from 8 males and 5 females. Total 13 people. 8 males, 5 females. If M is the number of ways the committee is formed, if M, small m is the number of ways the committee is formed with at least 6 males, and n is the number of ways the committee is formed with at least 3 females, you read again and again. You view the video, you watch the video 2 times, 3 times, 4 times to understand better. A committee of 11 members, 8 males and 5 females. Small m, what is small m? Number of ways the committee. Small m, the number of ways of the committee is formed with at least 6 males. Come to the question. At least 6 males. Number of ways when there is at least 6 males. How many males? 8 males. 8 is 6. Total 8 8C6. Total how much? 11. 6 plus 5, 11. So how many ladies will be there? 5 ladies will be there. 5 females will be there. Out of 5 females, how many females you have to select? 5 only, because total should be how much? 11. 11, 7 plus 4, 11. 8 plus 3, 11, like that. Or, plus means or. Once I told, or means plus. This is one case. Leave it. Another case may be like this. At least 6 means males 7, males 8. At least 6 means males 6, 7, 8, like that. 8C7 into 5C4. Total 11, like this. Or else, leave this case. Third case may be like this. 8C8 into 8 plus 3. How much? 11. 5C3. Like this you have to take. This is 78. 8C6 means how much? Calculation I told many times. 8C6 means 8C2. 8C8 minus 6. 8C2. 8C is NCR equals to NCN minus R. 8C6 equals to 8C2. 8C2 means here 2 is there, no. Here 2 is there, no. 8 into 7 backwards and 2 into 1 factorial. Like this you have to write. 8C2 is 8C6. 8 minus 6, like this. You have to reduce this so that you can easily write like this. Next. In the question what is given? N. N is the number of ways the committee is formed with at least 3 females. 5 females. At least 3 females. 3 plus 8, 11. 5 females. At least 3 means 4, 5. 3 cases. 4 plus 11. 4 plus 7, 11. 5 plus 6, 11. Like that. Total 78. M equals to N equals to 78. Here, the number of 4-digit numbers strictly greater than 4321, 4321, that can be formed using the digits 0, 1, 2, 3, 4, 5. Repetition of digits is allowed. Repetition of digits is allowed. Repetition of digits is allowed. Here repetition is allowed. And number of 4-digit numbers strictly greater than 4321, 4321, greater than this. You see here, 4321, first case. It's a common sense question. Common sense, general way on number theory. Number theory means what? The movements and the nature of the numbers and the behavior of the numbers. The study about the behavior of the numbers will tell or will give us the theory of numbers naturally. So here 4321, that's the what is this ones place? Unit place or ones place, unit place, tens place, hundreds place, thousands place. In ones place I am going to write. Here 1, 4, 3, 2, 1. I have written here for my for your understanding. This 1, leaving 1, and leaving 0, because if you keep 0, it will be less than 4,321. No. So leaving 0, leaving 1, 2, 3, 4, 5, we keep. 2, 3, 4, 5. We may keep 2, we may keep 3, we may keep 4, we may keep 5. How many ways? 4 ways. That is, 4 numbers will be coming. Is common sense? Yes, 100% common sense. Here, in unit place, I did not write 0, 1, 2, 3, 4, 5 numbers are given. No. I did not write 0, 1. Because if I write 0, it will be less than 4,321. If I write 1, it will be equal to this. What is the question? Strictly greater than case 2. I have come to units place and tens place. In units place, I can write 0, 1. Because tens place I am changing, no, 3, 4, 5. Either 3 or 4 or 5, 3 ways. Here we can write all 6 ways. 3 into 6, 18 ways. You can easily understand. 18 numbers will come. You see, 0, 1, 2, 3, 4, 5 you can write. Even second place also you can write. That is, I think, tens place also you can write. But in hundreds place, you should write 4 and 5. Because in hundreds place, 3 is there. Hundreds place 3 is there. Therefore, we have to write 100 place 4 and 5. This carefully we have to observe the movement of the numbers, the nature of the numbers according to the given condition. This is here 2 ways, 2 ways. This one 6 ways, 6 ways. Unit place 6 ways, 6 ways. Total 72 numbers. Here all you can write like this 6 ways. In unit place 0, 1, 2, 3, 4, 5 you can write. In tens place you can write 0, 1, 2, 3, 4, 5 you can write. In hundreds place you can write 0, 1, 2, 3, no problem. But here you have to write 5 because greater than this number. Greater than this number. So we have written like this. This is 6 ways, 6 ways, 6 ways, 6 ways, 6 ways, 6 ways. 216 ways. Total ways 310. The excellent question is given. All these questions in 2019, this question was discussed for JEE means. You see, all these type of questions are only given. General sense, with general sense and with general understanding and with along with common sense. The number of 6-digit numbers that can be formed using the digits, 6-digit numbers, 0, 1, 2, 5, 7, 9, which are divisible by 11, this thing, divisible by 11, divisible by 3, divisible by 2, divisible by 5, divisible by 7. These things you might have learned in 6th class, 7th class, 6th, 7th, 8th classes you have learned. Divisible by 2, divisible by 3, divisible by 4, divisible by 5, divisible by 6. In Ma'am's textbook it was there. If you forget, please go back to your sisters and brothers' books, 6th, 7th, 8th, 9th books, and you can go through it. Divisible by 11. And no digit is repeated here you see the fundamentals, the fundamental concepts. This divisible by some certain numbers are also important. Please go through and prepare it. Divisible by 2, divisible by 3, divisible by 5, divisible by 7, divisible by 6, divisible by 11, like that. For the divisible by 11, I want to tell you one thing. The sum of the given digits, I have total 24. Let the 6-digit number be A, B, C, D, E, F. And to be divisible by 11, what should we have to do? So the difference of sum of odd place digits and sum of even place digits must be either 0 or a multiple of 11. It means A plus C plus E minus of B plus D plus F either 0 or multiple of 11. Then A, B, C, D, E, F, the 6-digit number can be divisible by 11. This is the fundamental. You learned it in 6th class or 7th class. So for JEE Mains and Advanced, the 6th, 7th, 8th basics and basis of mathematics and in number system will be appearing in the questions. Hence possible case, therefore possible case I have taken A plus C plus E, odd places 1, 3, 5, 2, 4, 6, A plus C plus E equals to B plus D plus F. I have taken 12 because total I have done, that is why total I have done, that is 24. That is why I have taken 12, because half of that I have taken supposed to be like possible case I have taken, not supposed to be A plus C plus E equals to 12 equals to B plus D plus F. Hence possible case I have written. Now up to this is all the matter and knowledge you have learned in 6th or 7th class. Now I start solution. Now solution. ACE 057 because 12 possible case, and BDF 129 12 possible case, 9 plus 1 10 plus 2 12, or else means case 1 this is case 2. ACE set ACE may not be like this, may be like this 129, and set BDF may be like this 057, may not be always 129. Like that, 2 cases we have to take. Over. Now case 1. Case 1 I am taking 057. What is the arrangement? 3 factorial minus 2 factorial for this arrangement. Because these are 3 digits. But A is first digit here. Not first. A, B, C, D, F. Unit place, tens place, 100 place, 1000 place, lakhs place, 10 lakhs place. If there is 0 and 5-digit number will be coming, it is most dangerous. Here your requirement is 6-digit number. So here 0 should not be. 0 should not be. This is one kind of very small logic sense. because we want 6-digit number. Here should not be 0. But I am taking the first case 057. Therefore 057. Therefore what is the Right arrangement. 3 factorial naturally, but in the 3 factorial, 0 in 10 lakhs place will be coming, no. Then 5-digit number will be coming, no. Therefore, such arrangement is 2 factorial. 057 one way, 075 one way, 2 ways. 2 ways we have to subtract, and then 4 will be coming. These 4 ways we can give here number, here number, here number, here number, here number, here number, here number we can give. Here number, here number, here number we can give. Now BDF no problem, BDF no problem, 1, 2, 9, 3 factorial. So here first case, 4 into 3 factorial, 6, 4 into 6, 24. Second case, no problem. Second case, 1 to 9, no problem, 3 factorial 6. And in this case, 057. Where it is 0? B. B means where it is B? B is here, lakhs place. So no problem. 0 here we can take. 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 But we should not take here. If we take here, what will be coming? We will get only 5-digit number, not 6-digit number. But the requirement is 6-digit number. That is why we should not take in place of A, we should not take 0. That is why in the first case, that will be 3 factorial minus 2 factorial. In the second case, need not. 3 factorial equal to 6 and 3 factorial equal to 6. So 6 into 6, 36, total 60. So the number of 6-digit numbers, that can be formed using the digits 0, 1, 2, 5, 7 and 9, which are divisible by 11 and no digit is repeated, is 60. The number of 6-digit numbers that can be 6-digit number that can be formed using the digits 0, 1, 2, 5, 7 and 9, which are divisible by 11 and no digit is repeated, is 60. Thank you.